Welcome to Sundar's lecture. This is lecture number 34, and in this lecture we are going to see what is synchronous counter, synchronous up counter, synchronous down counter, and we will see an example how to design a mod counters like mod 5 counter, mod 6 counter, or mod 4 counter. So we will see step by step what is the procedure to design a mod counters with the examples, right? And what are all the topics we have seen in the previous class? This is the final slide we have seen in the previous class. We have taken flip-flop conversions, right? So one flip-flop to another flip-flop, and we have done all the combinations of flip-flop conversions. And this is the final table we have written for SR flip-flop. If you want to convert the SR flip-flop into D flip-flop, then what should be the S and then R inputs, as well as if you want to convert it into T flip-flop, what is the input for S and R, and so like this we have derived all the expressions for all the flip-flop conversions in the previous class, right? So now we will move on to the synchronous counters. Before that, I have not told you still what is the difference between synchronous and an asynchronous circuit, sequential circuits, and that I will tell you in a separate way, where what is the comparison between the synchronous and the non-synchronous asynchronous sequential circuits. Before that, it is very easy to understand that the design of counters without the knowledge of what is synchronous sequential circuit. Anyhow, I will tell you one simple point. If it is a synchronous sequential circuit, simply we know what is flip-flop, right? This is JK flip-flop. I have taken an example here for a JK flip-flop. Let us try to understand what is a synchronous sequential circuit before entering into this topic. Anyhow, I am going to tell you what is the difference between synchronous and then asynchronous circuit, sequential circuit, after this lecture, after completing the synchronous counters. Anyhow, see, if you give clock pulse, see this clock pulse is given to this flip-flop, as well as the same clock pulse is given to the another one flip-flop. That same clock pulse is given to the all flip-flops. That is the synchronous sequential circuit. Try to understand. If you give one pulse, then it will be applied to all the flip-flops simultaneously. That is synchronous sequential circuit. And if you go for asynchronous sequential circuit, these clocks are not simultaneous for all the flip-flops at a particular instant of time. That is the only difference. Anyhow, we will see that after. So what is now up counter? Let me explain you with this truth table. For example, I need to get the output of 000 if I give this clock pulse. Once this clock pulse is given, I need to get 000. And then if I give another clock pulse, that means first clock pulse, and I should get 001. And if I give this clock again, I should get 010. That is decimal of 2, right? And if I give the third clock, then I have to get 011. Right? That is the idea we need to do with the help of the flip-flops, that we can do with the help of flip-flops. That is what I have shown you here. Anyhow, we have taken 3 different flip-flops, and the outputs here, it is connected like this. For example, this is A, and this is B, and this is C. 3 outputs. That is what I have taken here. This is the output A, B, C. This is A, B, C. Okay. And then what we have done here, this first flip-flop, that means this JK flip-flop output has taken as A, and that is connected to the input of the second flip-flop. Try to understand. Let me write down. This is JA, KA. Let us be write like this. JA, KA. This is JB, KB. This is JC, KC. Right. so that you can easily understand what is the thing it is going to happen if you give a single pulse here. Anyhow, so what is the equation for JA and then KA? It is directly connected to plus VCC. What it in sense means, JA is equal to KA, which is equal to 1 always. If you give 1 to J and then K, what is the flip flop? What is the characteristics of the JK flip flop? If you give both input as 1, it is going to toggle. You know, right? So if J is equal to K is equal to 1, this condition implies it is a toggle. It is a toggle condition, right? We have seen these kind of stuffs already. Anyhow, so this is the equation. And what is the second one? What I am getting for the, because JB and then KB is connected. So JB, which is equal to KB, what is the input I am getting here? This is A, right? Output of A. So this is A. And what I am getting for JC and then KC, this is JC, which is equal to KC, which is equal to, see here, one input I am getting it from here, so this is actually A, this input is actually B, which means this is A, this is B. And what is the thing I am getting as an output? That means input to JC and then KC, it is actually A dot B, right? It is actually A dot B. So this is the 3 equations you should understand before entering into the working principle of this up counter, right? So what I am going to do now, let us assume that the outputs are 0 initially, maybe. So now if it is 0, 0 and then 0, right? So this is 0 in 0, 0, 0. Now what happens if I give 1 clock pulse now? If I give 1 clock pulse, what happens to the output of A? Since it is 1, 1, what is the output of A here? Already it is 0. Since it is 1, 1, it has to change to 1. It has to change to 1 simply, right? That is what here you can see at this instant. If I give clock, that means this 1, which means I am giving 1 clock pulse, 1 clock pulse. So this A is now toggled to get to 1. Sorry, this 0 is toggled to 1 now. And what happens to this B output? B output, it is getting an input from A. What is A? Actually, it is 1, right? It is 1, right? So what happens here? Oh, sorry. Okay, fine. Now this is the next stage, right? Next stage. Anyhow, so already it is 0. A is already 0. And if I give 1 clock pulse, so A is 0 here in the previous stage. You have to take this, not this. This A is already 0. That input would have been here. So it is 0, 0. It is 0, 0. What is 0, 0? In JK flip flop, J is equal to K is equal to 0. Then obviously it is no change condition, right? No change condition. Then what happens now? This stage, this output of 0 will be retained again. Simply it will be retained. So what happens to now at this C output? This C depends on JC and then KC. What is JC and then KC? It is actually already it is 0, 0, right? A is 0, B 0. You have to take this one. So if it is 0, 0, then the output this is 0, this is 0. Then the input to J, K will be again 0. So there is a no change condition again. So it will be retained at 0. So now this is the second condition. Now this is the state now. This is the state. Try to understand. This is the state. What state we are now? So this is maybe I will write like this itself. CBA. So now you have 0, 0, 1. That's what we have got after giving 1 clock pulse. Now if I am giving another clock pulse, now if I give another clock pulse here, now what happens? Now you rough all these things. Okay, anyway, I don't need to rough this anyhow. I will explain it from here itself. So now you see, if I give another clock pulse here, already it is very simple now. It is very simple since it is the JA and KA is connected to 1 by default. It is going to toggle for the next clock pulse. So what happens now? It is going to become 0. It is going to become 0. So now already A is 1 here, right? Already it is 1. So if I give clock pulse, then what happens here? already A is 1, so this is 1. Now if I give clock pulse, then this 1 will make this, since both are 1, then it is going to toggle. What is already here, it is 0, so it will change to 1, right? So now what is the next one? What is the next one? I am going to get what is C now. What is the output of C? That depends on JK, JC and then KC. And if you multiply these two, A dot B is the answer, right? A dot B is the answer. If you multiply these two, what you will get? You will get 0. So if it is 0, JC is equal to KC is equal to 0, then it is a no change condition. So whatever here, it will be retained again. It will be retained again. So this is the clock pulse number 1 and for clock pulse number 2. And if I give clock pulse number 3, again if I am giving like this, so obviously what happens to J and K, it is defaultly connected to 1. So what happens now, this 0 will now be changed to 1 simply, right? And now this A is 0 here, 0, that means this A is 0. If I give clock pulse, then this 0 is connected to JA and then JB and then KC, JB and then KB. So 0 means what happens here? No change condition. Whatever it is here in B will be retained again. Right? And now you see what is the how I am going to get the value of C. It is A dot B, right? What is A dot B? 1.0. It is 0. So if you give 0 to JC and then KC, it is going to retain its previous state, no change condition. What is this? No. Already it is 0, then obviously it is going to become 0. Simply. Can you understand? That is what here. That is what here it is, right? You please try to understand. Anyhow, now if I give 4th clock pulse, what happens? Obviously, this clock pulse, it is, since it is JA is connected to K is connected to 1, it is going to invert. So it is going to become 0 and A is 1. So what happens now if A is 1? Here it is 1, right? So JB and KB will get 1. If clock pulse is given at that particular instant of time, then what happens? This B output will be inverted. This, since you have A is equal to 1, that is what I have written here. So this will become now 0. And what is the input to JC and then KC? It is A dot B. So what is A dot B? What is A dot B? It is 1. Now it is 1. It has become 1 because A dot B 1.1 will become 1. And if this is 1, then what happens to C? Whatever it is in the previous state, it has to be inverted now. It has to be inverted. So this is 0. Now it becomes 1. Simply. So now this is the output you will get. And what is the next one? You will get for 5. If I am giving another clock pulse, again same thing. A will invert, so it becomes 1. And if A is 0, then this part has to be retained again because the 0 is coming here. JB and KB will get 0. 0 means the previous stage will be retained. So this will be 0 again. So what happens to this point now? What happens to this point? So this is actually 0, 0. A and B are 0, 0. So 0.0 will be 0. So this becomes 0. JC and KC will get 0. So it is no change condition. So you will get this one as 1 because it is already 1. So now also you will get 1 simply. And if I give clock pulse number 6, what happens? What happens? So now clock pulse number 6, it is 1. So obviously it is going to invert. So it becomes 0. And this is 1 now. A is 1 in the previous stage. So it will be retaining 1 here. So if it is 1, then the flip-flop will invert the output. So you give 1, so JB and KB will get 1 now. So it will invert to B. So this becomes 1. And 0.1, again A dot B, right? So 0.1, it will be 0. So if it is 0, then obviously this will be retained. This will be retained. Go for step number 7, that means clock pulse number 7 now. What happens now? So again J and K, so it is going to invert. So this is 0, so this part will be retained. And if you multiply these two, it will be 0. Again, this will be retained. This is the 7th one. Can you understand what is the thing? It is happening down. And after this point, If I give this next clock pulse, what happens? Maybe I will put it as X. If I give next clock pulse, what happens? What is going to become? Right. Now, if I going to give, so this becomes now 0 because A will be inverted. A will be inverted always. And this is 1. So, this part, this is, since A is 1, this part is going to invert, right? Because A is 1, JA and JB and KB getting 1. So, if JB and KB getting 1, then it is going to invert the previous stage. So, this become now 0. And A dot B is 1 1. So 1 1 means what happens here? Again JC and KC is 1.1, it is 1. So whatever the previous stage in the C becomes now inverted. 0 0 0. Can you understand? Can you understand? And what is this one? I am going to write this is again 0. Because it is 0 0 0, right? Again, if you give the nether clock pulse, it is going to count from 0 1 2 3 4 5. And if I give the another clock pulse, it is going to become 0 and then it is coming to 1 2 3 4 5 6. So it is again and again rotating between 0 to 7 count. So it is actually, it will count from 0 to 7, and if you give another clock pulse, it is again going to become 0. That's all. So can you understand the concept behind this up counter? Very simple. So if you know this equation, yeah, it will be very easy to understand, right? Anyhow, so the next topic, it is a down counter. It is down counter. And what is down counter? For example, let us take an example. So first, this is A. That means I have directly given here. This is A, this is B, and then this is C. Maybe we will take down here itself. This is C, this is B, and this is A. So try to understand all the outputs are 0 at the first instant. Let us assume that it is in 0. So what happens here now? So the connection is a different one. Maybe we try to write the expressions for JA is equal to KA is equal to what? JA is equal to KA is equal to plus 1. That is VCC, it is connected to VCC. So simply it will be 1. So this reflects the output of A. Right? This reflects the output of A. And what happens to JB? Maybe this is A, this is A, this is B, this is B, this is C, this is C. Right? And what happens to JB and then KB? What is JB and then KB? It is both are connected to A bar. Try to understand now it is A bar. This will reflect the output of B. Right? These two is going to get the output of B. And what is JC and then KC? JC is equal to K because both are connected. Both are connected. Right? JC and then KC, which is equal to what is the thing you are going to get here? It is connected from A bar. This is actually A bar. This is actually B bar. So what is this one actually? A bar dot B bar. What you can write this one? What is A bar dot B bar? Maybe I will write down this one here. A bar dot B bar, you can write it as A plus B the whole bar. Reverse of OR gate. Reverse of OR gate. That means NOR gate. Right? So now we try to write the expressions. So for example, this is count 0. Maybe now I am very particularly I can say that if I give one clock pulse, which means it is a 1 count. Right? So this is 0 now. This will be counted as 0. And what happens now if I give a clock pulse at this instant? At this instant, if I give a clock pulse, then what happens? I am giving clock pulse. So it is connected to 1 1. Right? JA and KA becomes 1. So obviously, what is the next stage? It becomes 1. And already it is A is 0. Try to understand. A is 0. But what is here? It is connected as A bar. A bar. Need to understand. Right? A bar means what happens now? If this is 0, 1 is given to JB and then KB. JB and then KB will get 1. So if it is get 1, then what happens now? Already it is 0, it will convert it into 1. Right? To understand it very clearly. Right? And what is the input for this JC and then KC? It is 0 0. Right? 0 plus 0 will be 0 and bar. It is 1. So 1 is given to JC and then KC. So if it is 1, then what happens now? whatever the previous stage, it will be now inverted. So it is going to become now 1. So what is this one now? 111 is equivalent to 7. Try to understand. 111 is equivalent to what? 7. Right? So this is now 7. Try to understand very clearly. Then if I give another clock pulse here, what happens now? If I give another clock pulse. So again J and K is connected to 1. By default it is going to become now 0. By default it is going to become now 0. And what happens to the JB and then KB? It is A bar, right? It is A bar. So it is 1. A bar is 0. A bar becomes 0. So if 0 is given, then whatever the previous state, it will be no change. So this stage will be no change as 1. Again A and B has to be R, and it has to give as R. If you are these two, what you will get? 1 bar. 1 bar means what? 1 bar means 0. So this JC and KC will get 0. 0 means what? It is going to retain the previous stage. What is the previous stage? It is 1. So what is 110? It is actually 6. Try to understand. Try to understand very clearly. Try to understand very clearly. And if I give another clock pulse, again I am giving another clock pulse. So again A is going to invert because it is a 1 is directly given. And it is 0. It is 0. A bar. A bar has to be given. So bar means what? 1. 1 is given means what happens to B now? It becomes 0. And these two are, you will get 1. You will get 1, right? So 1 bar will be 0. 0 will be given to JC and then KC. So if it is 0, then it will retain this one. What is 101? It is 5. Right? So if I give another clock pulse here, then what happens? This one will become 0. And this one will bar now, that is bar, which means it is 0. So 0 is given to JB and then KB. So 0 means the previous state will be retained again, 0. And 0 and 1 will be ORed now. If you OR these two, you will get 1. So 1 bar is 0. So 0 is given to JC and then KC. 0 means what? It is going to retain its old stage. That means previous stage will be retained. So now what is this one? Actually 100 is 4, right? You know already. We have seen many a times. And if I give another clock pulse now. So if I do that, what happens now? So this will be 1. And this is 0, right? This is 0. So bar. You take bar, it is 1. So 1 is given to JB and then KB. If 1 is given, then this 0 will be inverted. And try to understand, this is now 0, 0. 0 or 0 will be 0. And 0 bar is what now? 0 bar is what? 1. So 1 is given to JC and then KC. If 1 is given to JC and then KC, this stage has to be inverted. And what is this one? It is 3. Can you understand? Can you relate this equation with this diagram? It is very simple. And if I give another clock pulse, so this will become now 0. Simply, you know, now I can go faster. And this one will be inverted because A bar is given, right? So that is 0. So 0 means what? It is going to retain its old stage. That means previous stage. What is the previous stage? It is 1. So it will be retained. So 1.1, it is 1. 1 bar is what? 0. 0 is given means what? To JC and then KC. C will be retained. So C will be retained. What is this one? 0, 1, 0. It is 2. And if I give another clock pulse, I will get 1 here. So if it is 0, A bar is 1. A bar is 1. So 1 is given here. JB and KB will get 1. So it is going to invert this one. 0. And you see this is 0 and then 1. So if you are these two, 0 and 1, what you will get? You will get 1. 1 bar is what? 0. So 0 is given to JC and then KC. So if it is 0, then it will be retained. So what is this one? This is 1. Can you understand? This is 1, right? So what is the next one? If I give another clock pulse, so this will be inverted now. So it becomes 0. And it is 1, right? It is 1, right? So 1 means it is bar. So it becomes 0. It becomes 0. So 0 means JB and KB will get 0. So B will be retained. B will be retained. And what happens to these two now? A plus B. A plus B will be 1. And 1 bar has to be given. 1 bar means what? 0. 0 is given to JC and then KC. So what it is going to do? It is going to retain again 0. So this is 0. See, I am getting 0 here. Right? What will be the next stage? What will be the next stage? I've came to here now. Same point. same point. If I give another clock pulse, then what happens? It will go to 7. So from 7 to 0 it will come, and if you give another clock pulse, it will be go to 7, 6, 5, 4, 3, 2, 1. Right? To understand, this is the down counter. This is the down counter. If you give one clock pulse, assume that you have 0, 0, 0 in the output. If you give one clock pulse, it goes to 7. It goes to 7. And if you give another clock pulse, it comes to 6. If you give another clock pulse, it will give you 101, that is 5. I'm saying it 5, but you will get it as 101. And if you give another clock pulse, it goes to 4, 3, 2, 1 and 0. Again, if you give another clock pulse, again it goes to 7. Try to understand. Right? So the same way in the up counter also, if I assume that if it is 0, 0, 0, we give one clock pulse, it will get to 1. That means 0, 0, 1 you will get. If you give another clock pulse, you will get 0, 1, 0, that is 2. And another clock pulse, it will go up and then up to 7. After 7, if you give another clock pulse, it goes to again 0. So it is going to rotate again from 0 to 7, 0 to 7, 0 to 7, from 0, 1, 2, 3, 4, 5, 6, 7. So this is the up counter, right? So now you would have understand what is the synchronous up counter and then synchronous down counter. So what are the topics we have seen in this particular class? We have started with the synchronous counter. So this is the circuit diagram of synchronous counter. That means a design circuit of a synchronous counter, and we have written the equations for every A, B, C outputs, and we try to get the idea about how if one clock pulse is given, then it is going to count up. That means if it is 0, 0, 0, it goes to 0, 0, 1. And then if you give clock pulse at that instant, it is going to become 0, 1, 0, that is 2. And up to 7 it will go, and after 7 it is again going to come to 0, 0, 0 as a count 0. And this is up counter. And for down counter, this is the design circuit of a down counter. So in down counter, what happens now? If you assume that the outputs are 0, 0, 0, if you give one clock pulse, it comes to 7, right? 1, 1, 1. And if you give another clock pulse, it goes to 6, that means 1, 1, 0. And if you give another clock pulse, it goes to 5, and then 4, 3, 2, 1. And from 0, it is going to again jump to 7. So it is just counting down from 7 to 0. So you can also design a counter for counting 0 to 15 and 15 to 0. That means you need 4 flip-flops. That's all. Try to understand it very clearly, right? So it is up to you. So next stage you can go to 32 count and 64 count. So depends on that, you have to increase the number of flip-flops here, right? So in the this is actually, there is no restrictions in this down counter and then up counter. You give clock pulse, it is going to increase or decrease. Increment or decrement depends on which counter you are going to design, right? So in the next class, we will see what is design of mod counters. For example, I want to count from 0 to 4. That is mod 5 counter. 5 counts, right? 0, 1, 2, 3 and then 4. So you have only 5 different counts. So it is from 0 to 4. So if I give clock pulse, it has to count from 0 to 1. If I give another clock pulse, it has to go to 2. If I give another clock pulse, it has to go to 3. So and then 4. And if I give another clock pulse, it should not go to 5, it comes to 0. It has to come to 0. So from 0 to 4, it has to count from 0 to 4. So how to design those kind of counters? This is simple way. It is very simple. You can do it by yourself. Very easy to design these type of counter. But if it is a mod 5, mod 6, mod 3, mod 4, mod 10, whatever the counter you want, you can design it by yourself with a designed procedure. That is a procedure, right? That we will see in the next class. Thank you.